In this video, I'll be solving the fifth part of the first problem of UPSC Civil Services Mains 2018 Statistics Paper 1. So let x1, x2 and so on xn be random sample from uniform population over 0, theta. And m is the nth order statistic. We need to find m is unbiased but consistent estimator of theta. So we need to show this thing. So first, like if we take like m, so m is nothing but maximum of this x1, x2 and so on xn. So for uniform 0, theta, so the CDF, so the CDF of this x is nothing but probability of x less than or equal to x. So xi less than or equal to x, which is nothing but x by theta. For 0 less than, x is less than theta. So therefore, the cumulative distribution function of this m is nothing but probability of m is less than or equal to m. So if m is less than or equal to n, then all these x1s, x1, x2, all would be less than or equal to m. So xn less than or equal to m. So that is probability of xi less than or equal to m whole to the power of m, n, which is nothing but m by theta. So m by theta whole to the power of m, and 0 less than m is less than this theta. So therefore, if we find the density, so this is the cumulative distribution function of this m. So the density would be n times m by theta whole to the power n minus 1 into 1 by theta. For 0 less than m is less than theta. So that is nothing but n into m to the power n minus 1 by theta to the power n. For 0 less than m is less than theta. So that is the density. So now like expectation of m would be integral 0 to theta m into fm of m dm, which is integral 0 to theta m into n into m to the power n minus 1 by theta to the power n dm, which is n by theta to the power of n integral 0 to theta m to the power of m dm, which is n by theta to the power of n m to the power n plus 1 by theta to the power n plus 1 from 0 to theta. So that means expectation of m is nothing but n by theta to the power of m, theta to the power n plus 1 by n plus 1. So that means expectation of m is nothing but n by n plus 1 into theta. So we can clearly see expectation of m is not equals to theta. So that means m is biased, and we can also find the bias of m. So bias of m is nothing but expectation of m minus theta, which is n by n plus 1 theta minus theta, which is minus theta by n plus 1, which is less than 0. Now, so we have showed that m is a unbiased estimator. So now like we need to show it is a consistent estimator of theta. So like any estimator theta n, so any estimator theta n hat is consistent if this theta n hat in probability tends to this theta as n tends to infinity. So if I consider fm, the cumulative distribution function, so for any epsilon greater than 0, probability of m minus theta greater than mod of m minus theta greater than or equal to epsilon is nothing but probability of m is less than or equal to theta minus epsilon. So that is nothing but fm of theta minus epsilon, which is nothing but theta minus epsilon by theta whole to the power of n. So now like as n tends to infinity, we can see limit n tends to infinity theta minus epsilon by theta whole to the power of m, which is like something less than 1 whole to the power infinity, which is 0. So therefore m tends to theta in probability. So hence we can say m is consistent estimator. So we have proved that m is biased, but m is a consistent estimator of this theta. So that's it for this video. We'll meet in the next video.